Well, it's Sunday. You know what that means. Time to continue working on this game. It's funny, I was thinking just before the stream that we might be reaching a point in the project where the changes that I make even feel as impactful as the previous ones. Oh, hey Colin, what's up? Let me open the... Can I use this one? No, I'm fine. I was just about to start with the project. Instead of mentioning that after all of the changes that we made, maybe we start feeling like whatever new thing like that may not feel as impactful as the previous ones. So I was feeling a bit worried that we might be reaching the boring stage of making this game. Just a personal worry, nothing else. But putting that aside, we do have a couple of things that we can work on today. So let's go back to the list. Now, last week we did work on the spinner, that's done. But for the ball, I was looking as reference in other pinball games, how they handled animating that, because obviously I can use a 3D model for this. And I saw that in Pokemon Pinball, what they do is that instead of animating the ball rolling, they use frames for the ball rotating left and right, which I guess will be more convenient to animate, because you don't have to check every frame if it's rolling forward, backwards, or all of that, just to check if it's going to the left or right. And since the ball is going to go really fast for the player to notice, I guess it's going to be a good compromise. It will have some certain level of animation, but nothing too complex that you have to check every available direction to place a certain animation. So that's the animation I showed on Twitter the other day of the ball running. We'll see if that works. If it looks convincing enough, we can apply it to another feature sprite that will fit the theming, because the one I prepared was just as reference. And once you have that working, then we can move on to the other components of the RPG part of the table. Hopefully that will give us plenty of things to work on today. But yeah, aside from this, I'm getting a bit concerned that what could be left to do on stream. Because then we have what's working some parts of the UI, assets, testing, and that might not be as entertaining to watch. Now, I guess first things first will be to test the board. Let's see if I can run it here. Right, I cannot. Okay, this one goes away, and we'll use the default one. Because as you can see, the ball is rotating, but the shine effect rotates along with the ball, which isn't really what happens in the actual pinball. The reflection should stay at the top, but because that highlight is on the spray itself, it will move. So I will try a different approach for the ball graphics. So we have this sprite. Let me bring in the new asset. Actually, I got two different sprite sheets to test which one will look better. So let's make a new sprite today. And it's already way bigger, so we'll change that later. Now this one has how many? Right, 24 frames. Okay, this should look fine enough. No, I'm pretty sure there was a way to make it so that the sprite will not follow along the rotation of the body to the either here on one of its properties, or I will have to change that by code. Top level, transform. No, not this. Now we have to set this in code then. Yeah, let's bring the reference here, and I wonder if it's here or in the process function. Guess we can try here first. We said global rotation degrees, it's 0, so it stays in this rotation all the time. First, let's see if that's putting it at just that works. Okay, I think it did. But it did look a bit too dark, so maybe we can try the other sprite sheets. Okay, now here comes the complicated part. Instead of playing some animation to change the frames, we will keep the sprite just like we did with the spinner, a certain amount of impulse to charge a variable, and when that variable reaches its max point, then we'll change the frame. That way, if the ball has a low velocity, it will change the sprite at a slower rates, but if it has a huge impulse, it will change between frames way faster, so give the illusion that it's spinning faster. And because of that, we should check the code here. To compare with how we did it on the spinner. Let's see. Yeah, I think we can borrow the code from the process function here, and that should be enough. Actually looking again, the spinner works whenever the ball hits the area, so it's not something that it's doing it all the time. Because the ball will have its velocity updated on every frame. So I guess it should go over here, maybe in the physics process. Well, we can actually borrow some of this logic just as it is here, where on every frame we add to the impulse the value of the horizontal velocity of the ball, and then we check if it goes past 0 or past 1 for the limits. Now the thing is, because the ball is so small, we might not be able to truly be sure that it's rotating the way we want it to. Okay, so let's bring this. And let's do some small changes. Where she should have been able to hold how much it's been charged before changing the frame. Maybe frame charge would be good enough name. And here we change the spell frame. Did can we include? No, no more. Ah, no, it was wrap. Yeah, okay, it doesn't include the match value, so this should be fine. And we change it here too, but to the right. Now if the impulse here is 0, then it will charge. But now we still need to update the impulse, so we'll say elasticity, it's different than 0. Okay, this should be all the code we need. Okay, so first thing first, we keep the sprite rotation as 0, so the highlight effect doesn't rotate along with the ball. Then, if we're moving the ball horizontally, we will add the velocity to the impulse. And if there's an impulse, then we will use that to charge the frame variable. And when it's full, then we'll update the frame. And actually, let's use the absolute value. And then, depending if the velocity is horizontal or vertical, I mean, if the horizontal velocity is positive or negative, then we will update the frame. But we will never know in which direction. Then maybe we should use the impulse. Oh, hey Ranch, what's up? How's your Sunday going? So we charge this variable, but then what decides if the ball rotates to the left or the right? Should it be the linear velocity or the impulse? No, actually, I think it was right the previous way. Instead, this will start halfway. There we go. The coding is still going, and yeah, I'm still working on the pinball. I was maybe a bit worried earlier because we might be reaching a point of the project where we will start working, where all the things left to work on will be mostly boring parts to see, and it might not be entertaining to watch, because they will not be interesting features to see being coded. So while I was worrying about that, I was just coding a way to change the frame of the ball, depending if it's going to the left or the right, to give you some more animation. Okay, sorry, I was taking some coffee. Okay, so I think all we have left is to test if this is working. And for that, I guess we need to check the display itself. Alright, it won't let me see the sprite. No, that's too bad. Hopefully we'll be able to see that on the screen. And no, we can barely tell. Okay, maybe we need something else here. Okay, time to improvise a little thing. Okay, let's put it here. And behind the processor, let's make one here. So since we cannot see the ball frame rolling correctly, we'll just have to save its value on a label, just so we can be sure that it's working as we want it to. Okay, this should be good enough. So it rotated already. Could be the speed issue. Right, as you said, a limit. So we have to borrow this line too. And first we keep the horizontal velocity. Then calculate the ratio. And hopefully this will give us a slower transition between the frames. Because probably with the other way, the velocity was so high that it was charging the ball too fast. Still spinning. Maybe we'll need more information to see what's going on. Okay, so instead of this, we have the frame and we also need the impulse. Ah, no wonder. So that's why it was always spinning so quickly. So that means we need to calculate the impulse in a different way. Okay, so I would say most probably the issue is this line. How much impulse are we giving on every frame? Because it should definitely not be that high. But where are we failing? Maybe it should be just design. Huh, that's not it either. That's still too quick. Okay, that's much better. Now, if only we could see the sprite of the ball better, so we could tell that the frames are going as we would like to. And in case if we want to make it so the sprites last longer, then we could change the max value of the charge. So you can see it like this. And then here on the ready. The way it always starts halfway, regardless if it goes left or right. Now hopefully this makes it so that the frame change happens slower. And we are in a tricky situation because it looks and I feel like it works, but because the frames are the difference is so infinitesimal and the sprite isn't that clear when scaled down, we cannot tell if it's actually rotating the way we want it to. So I will probably have to make a new sprite sheet to test that later. Because ideally this is what it will look like. But you can only see this when it's zoomed in. It's possible to tell when it's in game. So that's unfortunate they didn't really consider that. Well, can be helped. I had to change this after the stream. But you can leave it at this now. Now next, I guess, will be this part here. These safety guards to protect the ball from falling off the board. and by that I mean taking this off, which actually, if I kept them the way it is here, it would be tricky to implement, because when do we consider they have to take them off? When they collide with the ball? Because the other way to implement this will be by carving here a square where the ball will fall, and then after some time it will plunge the ball back up. That could be another way of implementing it. Because if we keep this here, then sometimes after the ball touches this, they will, let's say, spin back to the board itself, so they cannot protect the ball anymore. You know what, I guess we can try making that way. And if it doesn't work, then we can always go back to the other one. Okay, so for that, let's make a new component. Let's call it guardrail. And let's borrow this polygon as visual reference. I see. So it copies the positions, but not the origin. That one might be a small issue. Because he will let me move all of the points. And because of that, if I rotate it, it will not go along the center. So I guess the only option will be to redraw the points. That's going to be very annoying. Unless I can use something else. I can use this as a pivot for the polygon. There we go. No, actually, I could have done this here on the base node, because we do have to rotate the whole thing. Okay, now we'll also need this collision. Okay, that's good enough. And now we need an area to detect when the ball hits the guard. Okay, like that. But I don't think we should make it so that it hits it covers the entire area, because you have to keep in mind the ball might go up here, or even hit it just for a second and it will not count. So just because it hits here doesn't mean that the guard did its job. Yeah, maybe we can only make it so that it covers up to maybe here. Okay, now we should give this and its variable, or just like some other components, a rest angle and an active angle. No, wait, rest angle will be 0, regardless if it's horizontal or vertical. And maybe they all should be aimed at the edge, so we can rotate better. Or maybe just leave it like that for now. Now this area will only collide with the ball. So when that happens, if the body is tall, then will create a swing. But we change the rotation, and right, it will itself to the active angle. Actually, first we have to give it a small delay. Maybe 0.2 seconds. Alright, but before all of that, we have to disable the area. Remember, we're here. I have to change this. So that when we reset it, it will check again the ball, and it will go to its default rotation to block the exit. Okay, hopefully this will be enough. Now let's replace this here. Okay, looks perfect enough. We can delete this. And this active body here. Now for this guardrail, we have to check which rotation will work. Okay, 30 seems to do the trick. And I will do the same on the other side. Alright, on this side, the rail was the different size for some reason. Even though it shouldn't be different. Please don't make me have to edit the polygon again. I guess for now we'll leave it as it is here. Okay, so we had that and the collision shape. Okay, let's see if those rails work. That is if I manage to make them hit those areas. Okay, it kind of worked, but not as I was hoping. Hey Copa, what's up? You just joined the right time to see the game do something stupid. And I think I know why. Yeah, here's the issue. I was giving the rotation the angle in degrees when I should be in radians. Okay, now it should work properly. That is, if I can manage to hit them again. There we go, now it's working. But maybe we should go a bit faster. Let's see if the rail resets. Yeah. Now all we need to do is test the rail on the right, and we can be sure that the component's working. Whatever, let's just assume that it works. I'm not gonna spend the next 15 minutes trying to hit that part in particular. Instead, let's cut this time here to 2.2 and just call it a day. And what else? Right, I guess we can make it so that every time the ball resets, we will reset those guardrails. Or maybe we can add that later, so we don't waste too much time on just that part. Okay, meantime, this is done. And I guess that makes it all of the basic components of the simple table. So now really all we have left is the RPG component. And just as we started the second hour, so I guess for now we are on a good pace. Now all of this is gone. Okay, and once more, we will delete the table here. Maybe now I can upload another version of the basic board with all of these components I've been working on this whole week to have an updated version. Ah, right, I never gave it its own audio bus. I guess I can do it now. Just so we can mute this so it's not as annoying when we are play testing. And I really forgot to set the references. Okay, just to check if everything's working okay. Okay, everything seems fine. Okay, now one last thing is to add those guardrails. So we'll copy this and put them here. And also deleting the collision shapes. Okay, now we can focus on the board. So going back to this, we have the flow, and here we have 3 components that we can work on to integrate on the RPG board. We have the spinner here, these targets, which we can add more on the other side, and these buttons here on top. Actually, I wonder if I can edit this. So that we can move this down here. Okay, now we'll move all of these 4 now here in the middle. Okay, now it will make more sense when we hit the middle of this canal here. But that still doesn't solve the issue of how do we integrate this on the game. Because when all 4 are hits, then something has to happen on the game. Another thing I was thinking of is to make it so that when all 4 are hits, the game will give the player a small damage buff that will let them hit critical strikes. At least for a certain amount of time. But how do we implement that? Should that be responsibility of the board itself, or should I make a new component to handle that? What to do? Alright, I just remember that I also wrote down some things to add later. Let me see the list. Pinball. Okay, we have all of the basic components, so I can remove this. Right, I was thinking of a way to give the enemies some basic level of AI. As for example, maybe give them a chance to dodge an attack, maybe. Also the ability to heal themselves or to debuff the player. As some examples of prolonging the duration of the game. So obviously the first enemy, we don't have any of these. It's an introduction to the game. But then later on, some enemies we have one or two of these AI features. So maybe we can add that as a feature on the resource. So enemy data. We can make a new category here. Maybe something like this. And then the bat has a, let's say, 20% chance to dodge an attack. And then on the board here, where do we check that here? If I'm in range, okay, this is the way. So if it's less than the enemy chance, then it will not hit. We will need to display something else. So on RPG screen, update live here. Maybe we can make it a new function so we can call it from outside. Okay, and now that we move that function, that outside on a function, we can make string like this. Otherwise, if it passes the dot chance, then we'll do this. And let's try it on this line. Let's give it a 50 chance to dodge. Alright, I forgot to change the angle here. Okay, so let's fix that quickly. Also, why did it show 0? And it should have done this. Right and integer. Okay, now it should be fixed. Yep, there it is. Okay, we know that works, so we can leave this for now. Actually, maybe we should make the font smaller when it starts. Maybe the colors should be inverted. So it's 32. How do I save this? Okay, like this. And when I show up, I can add an optional value of the font size. So we go here, we can say a default value of 42. Like that, so the miss pop-up will be smaller. I'm able to cover as much of the screen. So the ball didn't last long. Maybe the trick isn't to detect when the ball hits the rail, but when it leaves. Maybe that should be the approach. So instead of detecting when the body enters, it should detect when it exits. Okay, like that. Okay, so we know for sure that only when the ball leaves the area of the rail. And with that, maybe we can expand it a little bit. The detection area. Or maybe no, maybe we can leave it as it is. In that part, it seems to work. So I guess that's solved the issue, but I still not solve my skill issue while playing this game. But in any case, the dodge just does work, so we have that. And something I noticed is that thanks to moving the buttons down here, we could add a small screen here on top to let the player know when they have the critical buff. So that could be something else to add. And just like the RPG screen, we should make a component for that. So I will say include this screen here, and let's see how big should it be. Okay, so 152 by 48. And let's see how I did to do the effects. Okay, so we have the color for clipping. That's the HP bar. We need a color rectangle for the effect. Maybe in this case a black screen will help. Or maybe something somewhat gray, like that. Let's see how does this look. Yeah, and then when we activate all of them, we will place a level here says grid chance, and down here the timer for how long the player has left to use the buff. Okay, now here we make some labels for that. We need to copy this for the timer, so the numbers stay as center as possible. So instead we'll use this. Okay, perfect. That seems to work. Except it's not as center as I was hoping. Why is that? 1, 2, 3, 6. $22, $20. Too bad I cannot leave them completely center. Well, it have to be like that. Okay, this is for the timer. And here, let's say like that, and let's give it some outline. Maybe some blue. Yeah, but should be minutes and seconds. Maybe just 1 minute as a top will be fine. So I guess we don't really need this. Okay, like that, and some scripts to update those values. Okay, so at the start they will be both off. Now I wonder if I can make these also clips so they show up from the top and the bottom. Yep, it works. Okay, so we can make that effect. So let's again create a swing. And let's say it's parallel, so it will do both things at the same time. The property of the label, going to be 0 after 0.5 seconds. And the same with the second label. But this one should be at position 28. And I should also set the from where the wheels are moving. So where are we? Minus 24. And this one from where should we start? 52. I might as well move this to its own function. That way, when we want to reset the timer on the board, we can just call that function. And what else do we do to update the value of the timer? Here. Okay, we have the animation, we have the update of the value of the timer. What else? Okay, so visually we have all the components. Now we need to actually apply the logic to this. I wonder if it will hide it. Okay, it will. So that means when all of the buttons get hit, it should do something. Okay, it's this one here. Do we have a signal for this? No. So let's see if we have to make our own. And it should be here. Okay, so now we send a signal when all of the buttons get hit, which the board itself will detect. I never gave it its own class. Well, time to solve that. I now have to make this function down here. Okay, so if you only activate the critical buff if there is an enemy on screen. So for that, we say claim enemy. So if there is an enemy, then we will do something. Just like we do that, check with the bumpers. Alright, we will need a new timer for this. Okay, how that, and now we add a new timer down here. Yeah. Value, quick screen. Alright, I never added the reference. And the logic here is pretty much the same as with the battle timer. So the critical time is 0, then we have the screen, otherwise we come down. Right here. Okay, so we have a timer counting down, but nothing's happening during the bad side. So for that, we should have a boolean to keep track of if we have the critical active or not. And also let's set here by how much will the damage be multiplied. Maybe 1.5. Now when you just deal one base damage, it will not look as much, but if I end up implementing the incremental damage on the buttons at the bottom, then this multiplier will actually make a huge difference. So we will probably be relying on that later on. Here we go, got an enemy. Okay, let's see true. And if not, then false. Group, okay, here if we call the function for to show the screen. And wait until it's over. Should we freeze the screen? Well, this is happening, or maybe not. Okay, it's showing, and now we need to integrate this into the damage calculation. Maybe we should move all of this into its own function, now that we also have to control critical and dodge chances. So we'll move this here. Now here's calculating this one, but later on when we add the ability to increase the base damage, we will save this on a variable. But for now, leaving it here will do. Now here miss. The amount times the critical multiplier. Now let me check this in a new variable. Right, I should only do this if the critical is active. Okay, now it should be everything. Move all of this logic to its own function to calculate the damage. Pump only controls. Actually, should this callback control all of this? I guess it can do that for now. That shouldn't have happened. So I guess we do need to increase the area of the guardrails. No, wait, I just realized that I never set by how long the timer should go. So where do I set that? Right here. Now if only I could activate the critical up there easy. Maybe for now I could use another group to control that. We could make a new manager. Maybe we could put this here. And then when this button gets hit, it will activate the critical. So we go here, and the name of this one is free. Wait, what did it go for? That should not have happened. I don't think it's because they share the same shape. Just in case I will need to see the shapes of that. Okay, they're both there. Okay, now let's see if that button over there works. Yep, the critical seems to work, but no, actually it is working. I'm just terrible at the game right now, and we need to stop this. So when the game is over, yeah, here. I need to remember to add this later, because otherwise the timer will still be rolling after the game is over. But we do know that the critical works. And so I guess we can mark this as done. But I just realized I was using the wrong layer for that. Okay, we have this. Yeah, I think we can work now on the spinner component. I was thinking of a way to implement it to activate the gates for starting the battle. That way you don't have the ability to enter battle as soon as you start playing. You have to charge it here with these components. But for that we need to make a visual bar that will charge and some icon here to display that the player can interact with it. So I think that we work on next, but that will be after a small break. It's been 2 hours already, and after that, working with the spinner and the gate will be the last thing to do today, which should still be quite a lot of work. But we'll check that later, after the break. Okay, I'm back. Now all that's left for today, it's integrating the spinner with the gate for the battle on this board. Now the basic logic will be that when we add an impulse to the spinner, we will also add a value to the variable that will charge. Once that charge gets to its top limit, then we will open the gates. Of course, this can only happen when we don't have an active enemy on the screen. And so let's have a reference to the spinner if you don't have it already. Maybe I should put all the components on its own place. The screens, the components, yeah, okay. Okay, so here's where we find the spinner. Now, when do we send a signal outside the component that its value change? Should it be here on the impulse? No, probably here. Yeah, we should save all of this inside its own variable, and then we pass it on to the outside as a signal. Or maybe not, maybe only when this happens. No, or maybe when we change the angle. This is going to be the tricky part. Which variable do you use as a reference to indicate that the spinner change? Do we use the impulse amount itself or the status of by how much the angle change? Maybe it should be here. So we set up a signal here. Say spin updated, and then okay, and this will give us the value by how much it's got updated. So we go back to the board and we'll connect the signal. And as well separating all the functions. These are the board functions. Here are the signals. Okay, like that. Now the spinner will behave differently depending if it's in the middle of battle or not. I was thinking of giving it some functionality during the battle, but I haven't decided that yet. So I guess for today we'll focus on the outside the battle mechanic. So if it's got an enemy, we'll pass. Otherwise, and here we have to create new variables. Here I guess it's where we should create a progress bar for explaining how much it's been charged. But we will also have a setter so that when we set the value we also update it on its component. But should I do that now or after? No, we will need this now to be sure that it's working. Okay, so let's create one more component outside here. We'll select the spinner bar. And since it will go here, and let's see by how much. Okay, 80 by 16. value 1 and 0.3. Okay. Now let's give it some style, something basic. And here maybe some purple. Okay, this should be simple enough. It will do a trick for now. Okay, and that should be all for now. Now we will instance it somewhere here. And let's rotate it a bit. That should look good enough. Now over here, we create a setup for the charge. Right, I guess we can put all of these as UI components and board. Okay, back to this spinner value here. Okay, here's where we are charging the value, but maybe it's not that's good practice to have more logic here that will check if it's full or not. Okay, so back to this, when the spinner charges, if spinner charge is less than 1, then we update it. Else, here's where we will enable the gate for the bad cell. Which actually I don't think we set that yet. Should be some hidden up here. Okay, it's locked. Okay, here's the problem. When we start the game, we have to set this as locked. Drop. Okay, we set this as locked. Okay, ready. Just in case here too. Let me set the value here. Okay, we update it. So far so good. And here. Okay, so if charge is 1 and the gate is not locked, then we open it. Okay, that was quite a chunk of code that we don't even know for sure if it will work. Okay, he's hoping it will do a check on the first try. Okay, set 0. And we already see that the gate is locked. Interesting, went quickly to that value. So why was that? Spinner mount. Maybe is this amount that we are sending? Let's see how much we are sending actually. I see. So in that case, maybe we just need the delta. Ah, there we go, that's much better. But after just one spin, it does that. So we either need to lower this amount or increase the charge bar. There's still problems with this gate here. What's it going through? Right, because of this. No, wait, it doesn't make sense because the board should detect that. And now we see that the gate is active. It's weird that that collision shape doesn't detect the ball. That's strange because the left one does work. Could really be because of the scale. Let's set this somewhere else. Because now I'm really curious. Okay, the one does go through. So if I reset the angle, Yeah, that was the issue. I cannot scale this. This is the most annoying part of the whole process, having to manually adjust the values just because I can simply flip horizontally the components. I guess this is good enough. Yeah, this looks about the same. Okay, now I guess I need to adjust also the final angle of this. Actually, that will work fine. Okay. Now I guess if I move this, actually if I duplicate this, now the collision should work. Yep. Okay, that's fit. Now back to the spinner. Here we have this, and now let's try making some colors from where the bar is fully charged. But how do I change this? I wonder if this will work. Color if the value is less than the match. Otherwise, let's give it more vibrant color. Weird. So I guess this isn't the way to update the value. I need to look this up quickly. Let's see, set style. No, not this. Maybe like this. By default, it should be some of purple. There we go, that was a trick. So now when it's full, it will be yellow. Like that. Gets an HT50, that's good. And because the bar is full, I guess the next step will be to empty the bar. So let's go back to the board. Spin updated, okay, chronomy. And charge, it's 0. Okay, I think there's 2 more changes that we can do. One, increase this so that it takes longer to charge. Another one, it's a boolean to decide if we can charge it or not. Here. Set to true. So screen updated. If you cannot charge it, then we just skip the whole function. And here we set it to false, and then we wait. We set a timer so that it will take a bit longer before you can charge back. Actually here we can set this to false, but then when we enter the battle here, okay, here's locked, and then we can charge is 0, and then we can charge again. Man, I'm bad at this game. Okay, I think one more small change will be to change back the functionality with the spinner so that it will depend on how much impulse it's giving it. So for that, where's the spinner? Here. So maybe that's should I divide it, or that will make the value even bigger. I think this will be the opposite effect of what I was thinking of, which I will see. Yeah, the mount is minimal. So it should be delta times the impulse. Oh, that's still so quickly. Okay, that's much better. Now the bar charge is only relative to by how much impulse is receiving. I think just not noticed that when it's been the other way around, the value decreased. So maybe that's something that should fit. Now we can just enter the battle to test that. Of course, now the game won't let me try that. We enter the battle, and now I should be able to get to the critical button. There we go. But the gate is still open. I guess because I still had that from the battle ends. So we have to remove that. Here. Okay, and that's the flow of the battle now, with the spinner being part of the flow. With this change now, the flow of the gameplay is the ball enters the field, it has to hit the spinner to charge the bar, and once that's full, it will open the gate here that will let the player start the battle. Then the enemy appears and the bumpers will act as damage for the enemy. And if the player hits a group of buttons, it will initiate a critical bonus that will give a multiplier to the damage the bumpers can do. And thanks to that, now we have a lot of more interactivity between the components and the battle flow. Oh, actually, did quite a lot today. I'm not sure if it will be final, maybe we have to adjust some things, but now we have a lot more interactivity, which was the goal. And we managed to do all of that before the 3 hours. That's a good sign. So I guess we could call it that for today. Just mark this as finished. Let's see, yeah. Okay, so I guess that's will be all for today. Thank you everyone who stopped by. And probably think next week I'm going back to work. I will only be able to stream again on the weekend. So I'm sorry about that. But yeah, I will upload a video with this gameplay later tonight, and a new version of the demo for the basic table with all of these new components. So again, I think everyone could stop by to watch, comment, and lurk. We'll start right just now. In just a moment. Yeah, thank you everyone, and see you next week.